Hey everyone, and welcome to this explainer powered by QandAHelp. Today, we're going to put on our detective hats and solve a seriously tricky WASSCE 2026 physics question together. You know, getting comfortable with these specific past questions is literally the ultimate way to prep for exam day. So right now, we are going to crack wide open a concept that trips up a ton of test takers: electrolytic cell conduction. Let's get into it.
All right, let's jump straight into our case briefing. Here is the exact WAEC question, setting the scene of our crime, complete with 4 highly suspicious multiple choice options. The question asks, in an electrolytic cell, electric current enters and leaves the cell through, and then we have our 4 suspects. Is it A, ions, B, electrodes, C, electrolytes, or D, anions? Only one of these is the true culprit.
Now here's the thing. The absolute crucial linchpin here is the phrase enters and leaves. That right there is our ultimate clue to eliminating the wrong answers. In physics exams, test makers absolutely love trying to catch you off guard on the details. They aren't just asking what carries the charge. They are investigating the exact point of entry and the exact point of exit for the current.
To really crack this, let's use a simple analogy. Think of it like a big office building. Just as doors allow access to a building while people move around inside, the electrolytic cell has its own specific entry points and internal movers. I mean, if I ask you how you get into a building, you'd say through the front door, right? You wouldn't say you enter through the people walking around the lobby. Keep that exact logic front and center as we look at our options. So let's actually follow the path of the electricity step by step to clearly separate the external metallic circuit from the internal liquid part of the cell. Outside the cell, the charge is carried entirely by electrons flowing through wires. Simple enough. But to bridge the gap into the liquid cell itself, the current must pass through a physical conductor. That exact handoff point, that is exactly what we are looking for.
Okay, let's interrogate our first suspect. Option A, ions. We can actually confidently eliminate this one right out of the gate. Why? Because ions are the people moving around inside the building, not the physical doors where the current enters or leaves. Yes, positive and negative ions are absolutely essential for moving the electric charge through the liquid, but they do not connect the cell to the outside circuit. What about option C, the electrolytes? Well, that's literally the environment, the building itself, where all this conduction happens. So we can cross this suspect right off our list too. It's the liquid or molten substance containing all those busy mobile ions. Saying the current enters the cell through the electrolyte is kind of like saying you enter a building through the building. It just doesn't make logical sense for what we're trying to answer. Moving on to clear another suspect, let's look at option D, anions. Actually, anions are just a specific type of ion carrying charge internally, which means they for sure aren't our entry and exit terminals either. They're just the negatively charged ions moving toward the positive anode. They do great work inside our liquid environment, but they are definitely not the physical connection point to the outside world. That leaves us with option B, electrodes. And bingo, that is our definitive answer. The electrodes are the actual physical conductors placed inside the electrolyte. One electrode acts as the door allowing the current to enter from the external circuit, and the other door allows the current to leave. Mystery solved, just like that. Okay, pause for a second, because I want to share a massive exam shortcut with you. Keep this insider secret in mind. The phrase enters and leaves almost always points directly to terminals. And for an electrolytic cell, those terminals are the electrodes. Whenever you spot those exact keywords on your WASSCE or JAMB exams, you can instantly bypass all the internal mechanics and look straight for the physical connection points. It's a huge time saver.
Let's do a super quick recap to lock in these stark differences before we test your memory. Electrons own the external metallic wires. Cations and anions completely own the internal electrolyte. But those crucial entry and exit points, those belong solely to the electrodes.
All right, case closed on that main question. But let's see how sharp your detective skills really are right now. We're going to do a rapid-fire quiz round with 3 questions straight from past exam scenarios. It's one thing to hear me explain it, but actively pulling the information from your own brain is how you truly master this for test day. Ready? Let's go. Question 1. See if you can recall what acts as the people moving inside our building analogy from just a minute ago. In an electrolyte, electric charge is mainly carried by A, atoms, B, ions, C, electrodes, or D, neutrons. Take 3 seconds to lock in your choice. If you went with B, ions, you absolutely nailed it. Ions do all the heavy lifting of carrying the charge through the liquid. Remember, both cations and anions are moving around in there as the mobile charge carriers that make internal conduction possible. Okay, let's turn up the heat a little bit for question 2. We need to figure out the specific name for the positive terminal of our cell. The electrode connected to the positive terminal of the power source is the A cathode, B anode, C electrolyte, or D cation. Think about the terms we use to describe those two different doors. The answer is B, the anode. And hey, here is a really handy trick to remember this. Negatively charged anions are always attracted to the positive anode. Anions to the anode. Let me say that again, it's so helpful. Anions to the anode. It's a quick alliteration that will absolutely keep you from mixing up your positive and negative terminals when you're under pressure during the exam. Last one, question 3. Apply the universal rule of opposites attracting to deduce what moves toward the negative cathode. The options are A, anions, B, cations, C, electrons, or D, neutral atoms. If you just used the shortcut we learned for the anode, you can totally reverse engineer this one. Brilliant job if you picked B, cations. Their positive charge naturally draws them straight to the negative cathode door. Just remember that foundational rule of physics, opposites attract. Just like magnets, opposites attract, so the positive cations flock right to the negative cathode. If you want to keep this momentum going, and you absolutely should, you've got to utilize the reviewer-checked library over at QandAHelp.com. Organizing your study time by topic and similarity, maintaining your daily streaks, and seeing your name climb that leaderboard, it is literally the best way to prepare smarter, not harder, across all your WAEC and JAMB subjects. So, as we wrap up this explainer, I'll leave you with this to think about. How many more hidden clues are waiting for you in your past questions right now? Because let me tell you, every single past paper is packed with these little tricks of phrasing just waiting to be deciphered. Stay curious, keep building those study streaks, and I will see you all in the next explainer.